Welcome to Tufin 2020. My name is Reuven Harrison. I'm the CTO and co-founder of Tufin. Tufin is an opportunity to share your experience in the domain of security policy management, to learn from others and to teach others. You represent some of the largest companies in the world, and as such, your voice is important in establishing the future of this domain. We've been working with you for 15 years, and as a result, we developed a deep understanding of this domain and its challenges. So I'd like to share some of that with you today. And I invite you to share your questions and thoughts with us as I go along. So let's start. This is a traditional on-premise network. This is probably the network that a lot of you are still managing today. Okay? Within this network, we have multiple domains or multiple security zones. And this is a very typical example where you have the untrusted zones, and then within the organization, you have some more secure zones. And what you usually do is you deploy firewalls between these zones, and they protect or segment the network, right? Now this is very standard, and we are moving to the cloud, and we'll talk about that in a moment, but this is probably the vast majority of what you guys are doing today. And the problem is, as we've seen in the past 15 years, policy management is difficult. Okay? Even if you only have 50 firewalls or 300 firewalls, it's still difficult. And what we see across all of the deployments of Tufin, the vast majority of our customers have policies that are overly permissive. They allow more than you actually need. And that goes against one of the fundamental principles of security, which is the least privilege principle, right? You should only allow what is needed for business. And the reason that happens is because policy is very difficult to manage. We'll see in a moment in more detail what that entails. But we also see a very common problem that the change process is too slow. And it holds back application owners and developers. They're usually in a mode of waiting for security to approve their connectivity so that their applications can go into testing and production. And as a result, developers often try to avoid security, especially if they can, if they're running in the cloud, if they're running in environments which security might have not already covered. We also see, as a result of these difficulties, failed audits and lack of compliance. And ultimately, we see data breaches. We see that every day on the news. And that's also a result of the difficulties of managing a security policy. Now it's becoming even more difficult because the traditional network is expanding. It's expanding to cloud, to IoT. The WAN is becoming larger, SD-WAN if you like, mobile networks. The network is becoming much more heterogeneous, and as such, it brings more problems with it, or more of the same problems, I should say. There is also an interesting new technology that is approaching us and will become very important in the coming years. That's edge computing. And as you can see here, a prediction that this will become even bigger than cloud security or cloud networks. So the network is going to be heterogeneous more and more over time, and that's going to cause bigger problems with security policy management. Here's an example of what a future application looks like. It's actually current for many of you, but moving forward, this is going to be the standard with applications. So applications are going to be deployed across multiple clouds, okay, and they're called multi-cloud applications. Here's a simple example where an application consists of some workloads that are running on-premise, perhaps on some VMs, and also they have access to a back-end server or user database or mainframe or some other system that's running on-prem. And then we have elements of the same application that are running in the cloud, maybe on Kubernetes, maybe using cloud storage and other services in the cloud. Here we have also an example of the application which is performing authentication, user authentication with an external service, right? Many services today providing user authentication, and the user that connects to the application. Okay, so it's a simplified application, but you can see that it's composed of multiple clouds. The code that developers write is actually just the glue that combines all these components. Actually, one of these important components is open source too, right? Developers today use more and more open source components, and they combine them together using code that they write. It is practically impossible for any single person to be an expert in all of these technologies and platforms. And they're also evolving very rapidly. So Kubernetes, for example, has a major release every quarter, and the cloud providers release multiple new services every month, right? So it's very difficult for anyone to understand these applications end-to-end with all their platforms. And as a result, we see a continuous rise in complexity and also in security breaches. This is the result of the complexity, right? And this will continue. Security will continue to be more and more of a challenge and a problem for large enterprises, but for small enterprises too. I'd like to bring up this controversy, which has been around for a few years, and I'm sure you've heard about it too. It's about the relevance of firewalls as a security control in our networks. And in 2015, during an apps security conference, Alex Stamos, who was CISO of Yahoo and later became the CSO of Facebook, said that firewalls will soon become irrelevant. And he talked about a few different reasons for that, and here are three of the main reasons. First, he said that the firewalls don't scale to the very fast networks that we have today. They won't scale and they'll be too expensive. Secondly, Alex said that firewalls cannot be used to do east-west segmentation. They cannot see the flows between VMs, for example, or other workloads. And thirdly, maybe as an extension of the previous idea, he said that containerization will collapse the security perimeter. And according to Alex, the solution is application security. We should move away from firewalls and focus on application security. Now, I'm going to address this controversy in the next few slides. So, first of all, let's see where we have firewalls today. And this is probably relevant to most of the organizations. So, if we have this typical multi-cloud application, we're going to have a firewall at the perimeter. Okay, so people have been saying that the perimeter dissolves and is no longer relevant, but we still have firewalls at the perimeter, and nobody's going to drop these firewalls. Then we have internal firewalls to segment between the security zones, just like we saw on the first slide. We also have firewalls in the cloud. Sometimes they're not necessarily called firewalls. They could be called security groups or application security groups or network security groups. But in essence, they are firewalls because they segment, and they segment between east-west traffic as well, right? And then we also have a new kind of entity, which is a firewall as a service in the cloud. We see it with Microsoft Azure, a very successful firewall that you can consume as a service. And we expect to see more of these firewalls in the cloud. So you can use a standard Checkpoint or Palo Alto or Fortinet or Cisco firewall in the cloud, but you can also consume a firewall service in the cloud. And then we also see firewalls segmenting between VPCs or VNets in the cloud. So we see firewalls for the north-south connectivity in the cloud as well. That's very standard. So we have quite a lot of firewalls. They haven't gone away, and they're still relevant. Let's see another kind of firewall that maybe you don't refer to as a firewall, but in essence, it's doing the job of a firewall. So this is the identity firewall. And you may have also heard the concept that the future firewall is identity, right? And we're seeing that happen in the cloud right now. So for example, we have identity access management, IAM policies in the cloud to protect services and segment between them, who can access this service, who can read from this storage, who can write to this storage, things like that, right? And then we also have authentication services. They're actually identity firewalls as well, because they determine which users can access which aspects of the application, right? And thirdly, as another example, inside of Kubernetes, which is a microservice platform, there is an RBAC model, just like IAM in the cloud, same thing. We have RBAC in the application as well. But in Kubernetes, it's modeled with a nice language that can be used to define the rules, who can access what. So identity is also a firewall, and we see more of these in the cloud. There's also this related concept of zero trust architecture, which is becoming more and more important. And this idea is never trust, always verify, right? And we actually see the consolidation of network security and IAM. That's happening. And it applies to humans and machines, or processes or workloads alike, right? It applies to any entity that needs to connect to any other entity. Who can talk to who, and what can talk to what. But that's not all. We have additional types of firewalls. And again, you may not have been referring to them as firewalls, but in essence, they're still doing the same thing. Who can talk to who, and what can talk to what. They're enforcing these policies for us, right? So I want to talk about OS level firewalls. Okay, and it's something that maybe network security people don't consider part of their domain, but I can tell you for sure that developers and application people, they don't consider it part of application logic either. So somebody needs to control it, and often what we see in practice is that these policies are very permissive, or maybe just not even there, right? Just by default allowing everything. So it's very, very important to do this kind of thing in a Kubernetes cluster, for example. Isolation at the OS level is maybe ignored on a standard Linux machine, maybe. But when you're using Kubernetes to do micro-segmentation between containers and workloads, it's actually built into Kubernetes. So there is the concept of C groups and namespaces that are used by Kubernetes to isolate the workloads. And then you have SE Linux or AppArmor or SecComp, which are types of policies that you can enforce to do additional segmentation and to restrict the workloads from what they can do at the operating system level. Here's one last example of firewalls that, again, you may not necessarily consider as a firewall, but for all purposes, they are firewalls. And these are application level firewalls. Proxies, load balancers, application gateways. The proxy might be running on your network, maybe doing egress control, who can go out to the internet. They may be running inside a Kubernetes mesh, a service mesh, or they may be running as a load balancer. Load balancers are proxy, and proxies are very similar in what they do. And there's this new, relatively new concept of an application gateway, which sits in front of your application and also provides security amongst other things for your application. Now, WAF is another example, right? A web application firewall. It's an application level firewall. And these are all firewalls with policies that need to be managed. And in essence, what I would call a firewall is anything that enforces a policy of who can talk to who or what can talk to what. So coming back to our controversy, Alex Stamos said that firewalls will become irrelevant in a few years, but in practice we're seeing more firewalls. And it really depends of what you consider as a firewall, but if you take the more generalized concept of a firewall as something that enforces a policy of who can talk to who and what can talk to what, then we see more firewalls, more types of firewalls, more technologies of firewalls across the different layers and scopes of our network, right? And I've kind of sketched out a few ways of thinking about this. The scope could be subnets or security zones or containers or workloads or users or applications, right? And the vector that we're protecting is another kind of dimension, the network vector or the operating system vector or data, file systems or API calls, or the supply chain, which is also becoming an important attack vector. So coming through the supply chain means maybe injecting malware into an open source package that we're using in our code. So you want to protect at all these different levels, vectors. And finally, the tools that you use to enforce your policies. And I just call them firewall tools in general. They could be network firewalls or next-gen firewalls. They could be security groups in the cloud, or proxies / load balancers, or a web application firewall, or SE Linux, or agents on your machines. Anything that can enforce a policy. So a firewall is anything that can enforce a segmentation policy of who can talk to who and what can talk to what. So what is the purpose of having all these firewalls in place? Because obviously it's a burden, right? Managing them, deploying them, configuring them. Why do we have them? We have them there to prevent attacks. And attacks apparently have a kind of a template or a pretty standard way of progressing from entering the network all the way to stealing data, for example. And MITRE has done a good job in breaking down these steps. And it's available on the internet for free. If you're not familiar with this, I really recommend take a look at it. It's called the Attack Matrix for enterprises. And you can see how an attack usually happens. So it starts with initial access and then execution and the other steps that I'm not going to go into. But if you have a good segmentation policy deployed across multiple levels and scopes, as we've seen, then there's a good chance you can prevent a lot of these steps. And that's really why you have all these firewalls there. Coming back to the controversy, Alex Stamos mentioned that firewalls will become irrelevant in a few years. He also mentioned that application security is the answer. And I want to just take a look at that for a moment, because there is this claim that application security can replace firewalls, but that also means that we need to trust developers, because they're the ones who are doing application security. And the question is, can we trust application developers for security? So from some aspects, yes, we can, and we need to, because application security is critical, and a lot of the attacks can be prevented if you develop applications correctly. But the problem is also that you don't know what developers have done within the applications, because there is no policy. And I say, show me the policy. If you can't show me the policy, I can't trust it, because I don't know what you've done. So we want to engage developers to enhance security, but we can't necessarily rely on them fully, because we need to see what they're doing. Also, keep in mind that developers are not experts in security. So even though they might do a good job in thinking about potential attacks or potential vulnerabilities in their applications, they're also going to miss some, because it's not their expertise, and they don't think like an attacker. They think like a developer. And mostly, the main reason why developers cannot be trusted for security is because developers are not measured by security. They're measured by velocity, by how fast can you make this application work? How fast can we release this new functionality for our customers, right? And that contradicts security a lot of times, because when you want to allow an application to be deployed quickly, you're going to be as permissive as possible. You're going to open up all the access that you need just to be able to get that feature out in time. And that's what happens in a lot of the cases. We have policies with allow any, just because we're trying to release. And then what happens is that that policy just remains there forever, right? A temporary solution becomes the fixed solution. Writing and managing policies is extremely difficult, because you need to balance security with business. And they often contradict each other, right? Too much security means business continuity problems or connectivity problems. And too much connectivity means attack vectors or attack surface. So balancing these two forces is very difficult. And as a security manager, you're the one who's walking that fine line. It's a very difficult trade-off to make, and it needs to be made continuously. I love this quote, and I'm sure you've heard me saying it before, and I'm going to do it again. This quote is about nothing is permanent except for change. It's by a Greek philosopher called Heraclitus. And what he said originally is that you cannot cross the same river twice, because the river changes. But also you change, and everything is changing. And in networks and in IT, this is very true. You're deploying new applications. The applications are being changed. The architectures are being changed. We're moving from traditional network security to zero trust architectures right now. We're moving to cloud. We're moving to IoT. We'll be moving to edge compute in a few years, right? So everything is changing all the time, and doing security once is not enough. You need to do it continuously. And that makes the problem of security policy management even more difficult. Let's take a look at a typical security policy lifecycle in a typical organization. It begins with somebody writing the initial policy, right? That person is usually not around, because that happened many years ago. And now what we have is a policy which has many holes in it, because over time, application people have come and requested connectivity that was not considered in the original policy. And we punched holes, right? We opened up more access. So Reuven refers to this as Swiss cheese, right? Our policy is full of holes. And these holes are necessary for business. That's okay. It's aligned with the principle of least privilege. But what we fail to do very often is seal the holes once they are no longer needed. So these holes remain in there. But luckily, you use tools like Tufin to remediate these holes, right? To fill them in, to detect unused rules, unused objects, to do automatic policy generation and replace very permissive rules by more specific rules, and also to automate the change process of requesting and approving and documenting the holes that you punch in your policy. So this is a kind of simplified security policy lifecycle, because in practice it involves many stakeholders. It involves multiple change management tools, different business processes, policy languages, and more. But at a high level, this is what a policy lifecycle looks like. And it's very challenging because, as I said, it's continuous. It needs to be continuously done. Now, what's happening is that our change rate is accelerating, right? The velocity of the applications that are being deployed is much faster than it used to be 5 or 10 years ago. And as a result, our security needs to be much faster. So we say automate, right? And a lot of you are automating. A lot of you have automated the change process. And some of you have done zero trust change automation, which is great because that improves accuracy, it improves the quality of your policies, and it also segments your networks better. But developers are moving so fast today that they're usually not willing to wait more than a few minutes for a policy to be applied. So they use this, this slogan of move fast and break stuff. I'm sure you've heard it before, right? And it breaks the policies too, right? So we need to be prepared for that. And one of the ideas that we came up with here in Tufin, maybe a few years ago, we talked about automatic policy generation, and a lot of you like that and use that. I've seen customers doing that successfully on their firewalls. But now we can take it a step forwards, and this is a new concept that we've built into TOS, into Secure Cloud, which is aligning the developer processes with the security processes. What we're saying is you need to embed security into the CI/CD, the development processes, the continuous integration and continuous deployment. So there's this concept that developers apply, and it's a good concept. It's test-driven development, which basically means every piece of code that I write has tests to test it. And while you're running these tests, you can build a security policy. You can build the fingerprint of how the application or the component is supposed to behave based on these tests. And that could be the baseline of your policy. And you could use that to generate policies on the fly at the speed of developers. So it's very new. It's a new concept. We actually call this immutable policies because it means that you don't need to adapt the policies that are deployed in production. You generate a new policy every time an application is changed. But you also need to reconciliate it with the policies that are actually running in production because things that happen in production may never happen in tests and vice versa. So this is something that is still evolving. It's a new concept. But what's nice about it is that it aligns development motivations with security motivations. And it brings them together to solve a problem together rather than in a conflict. Okay, simultaneously with the evolution of our networks to become more heterogeneous and using different platforms, we also see this shift in applications becoming more software-driven and less IT-driven. So if in the 80s or 90s we were using a lot of physical servers, maybe VMs later on, and then the VMs became services in the cloud and containers and the orchestration and Lambda functions, which are pure software. Today, a lot of the applications or the developers use pure software only. They don't have any touch points with the underlying infrastructure. And that means, first of all, that IPs are less relevant. So we use less IPs in our policies. We use other identities because a Lambda function, for example, you don't even know which IP it's going to be run on. It's a service, so there's no IP to protect. So use different types of languages. That's one impact of this shift to software. But the other impact is that we have a much smaller scope, for example, a microservice or just a single function. And this rich context allows us to write better policies. It allows us to do micro-segmentation. Here's an example of micro-segmentation. Okay, rather than just saying this IP can talk to this IP, we can now say much more. We can be very precise. We can say this service can talk to this service. And we know exactly what kind of service it is and what the service does. But we can also go deeper and say this process can talk to this process, right? We can go all the way down to the process level. And this micro-segmentation allows us greater control and greater segmentation, which is good for security. Moving forwards, we can also talk about API security because at the end of the day, when applications are talking to each other, they're using APIs. And we can go all the way up to the API and segment at that level as well. So this shift to software enables us to do better segmentation. So based on everything that we've seen, here are some conclusions and some working assumptions for you to keep in mind as you manage your security policies. First of all, you should assume a multi-vendor, multi-cloud, heterogeneous reality, because more and more our networks are going to be that kind of heterogeneous network. Secondly, because they're heterogeneous and implementations will change, you want to have a higher level policy that is abstracted away from specific implementations. Next, you also want unified and central management. Okay? You want to get that central visibility across the different domains and different platforms. And you also want to be able to control who can talk to who and what can talk to what across these different platforms. Now, controlling doesn't necessarily mean enforcement. It could just mean alerting or even just visibility to the violations. But you need that unified visibility. Also, you need to assume that policies need to be adapted continuously. And writing a policy once is never sufficient because, as we've seen, change is inherent. So you need to be able to learn and adjust and optimize policies continuously. And ideally, you want to do it at the same speed that the developers are changing their application. So you would like to integrate your security controls into the developer processes. Remember that 99% of firewall breaches are a result of misconfiguration. This is a result of Gartner's research, and it makes a lot of sense because the enforcement itself is actually quite bulletproof. It's been developed over many years by specialists, but the policies are what you are responsible for, and they're very vulnerable because of all the reasons that we mentioned, because of the difficulty of managing a policy. Finally, I want to say that a policy should be a first-class citizen. It is for us, obviously, because that's what we do all day long. We develop tools to manage policies. But for you, for the security managers, you should also think as policy as a first-class citizen. And that entails a few things. It means, first of all, everywhere where you're enforcing a segmentation policy, there is a policy, right? So any segmentation tool, not just network firewalls, they have policies, and you should think of them as a policy. The policy actually acts as a valve between business and risk. So it's a trade-off between how much connectivity you're going to allow versus how much risk you're willing to take. And that's your policy that controls that balance. The policy needs to be visible, and it needs to allow you to control the segmentation, right? So show me the policy. If you can't see the policy, you can't trust it. Therefore, policies that are maybe enforced inside of an application that is written in some programming language is not something that you can trust because you cannot see it. The policy has a lifecycle, as we've discussed. It's established as a baseline, and then you punch holes in it, and then you seal the holes as they're no longer needed. And this lifecycle is continuous. And ideally, you want to change the policy at the same speed as developers are changing the applications. And to do that, you need to embed your security policy lifecycle inside of the developer processes, the CI/CD. Thanks for spending this time with me. I hope you found it interesting and useful. This is actually a summary of what we learned from you over the past 15 years. And this is what we're here for today, to learn from each other. This is also the blueprint of our vision. This is what we're building for you, these solutions that will be used by you and many other organizations to manage their security policies. And I'd like to invite you now to stay with us for a live Q&A.
All right. So I hope that you found some of the points that I discussed interesting and useful and relevant to policy management, your daily activity. I'm going to follow up now with a few questions, and I'll try to answer them as best as I can. I'm going to start with a question that was actually asked on the last week on the Americas event, and then I encourage you to submit additional questions now. I'd really like to interact with you live. So I'll take this question, which is about the simplified policy lifecycle that I mentioned. That was only 3 steps, and people have asked, what is a real life example of a policy workflow in a large enterprise environment? So typically there are multiple workflows for different use cases. For example, opening access, rule decommission, server decommission, and a relatively new workflow that we introduced recently, which is cloning server policy. So you have different workflows for different use cases. And the flow often begins with a corporate change management portal like ServiceNow or something that maybe we develop for some of our customers, or the customers develop themselves. And then self-service, submitting an access request or some kind of change request. It goes through approvals. It goes through a security assessment. Some of you have unified security policy defined. You can integrate that into your change process. And as you'll see later on in Tufinovate, we have an extension of that will allow you to perform additional tests as part of the workflow. And then implementation. More and more of you are doing fully automated implementations, which is great. Automation is good for business, so I encourage you to do more automation. And when the ticket is finally implemented, whether it's manually or automatically, we want the documentation. So secure change can take care of documenting the rules and the changes as well. Then you have an automated audit trail. Finally, after the workflow is completed, the application people usually want to test it and make sure that it's working according to their requirements, and that kind of closes the workflow. Okay, a couple of questions that came in right now, live questions. So somebody said that he enjoyed my session. I really appreciate that. Thank you. And then what's the roadmap items for Secure Cloud? So regarding Azure Firewall, visibility of changes, for example, username to which user performed the change on an Azure Firewall, just like Secure Track. Will this be possible in Secure Cloud in the future? Absolutely yes. Azure Firewall, we just very recently added to Secure Cloud. Not change management yet, but full visibility to all of the rules, all three types of rules on Azure Firewalls, as well as the cloud network topology. That's already supported as of today in Secure Cloud. And you'll see more features around Azure Firewall in Secure Cloud. Next, permissive access. Will this include Azure Firewall rules relevant to the asset under security access in Secure Cloud per asset in the future? Yeah, so generally speaking, all the features of Secure Track will be available for Azure Firewall. It's just a matter of time until we roll them all out. Additionally, we'll have special features for the cloud capabilities of this firewall. Last question from the same person, Identity Access Management, IAM. Is there a roadmap item for IAM rules per asset in Azure for Secure Cloud? It's already supported today, available in the product, but there will be more of that as well. Next question, when are Cisco SGT or EPG supported in Tufin workflow? Very good question. Okay, so EPG relates to ACI, and there is visibility today for EPGs in Secure Track. We are currently debating whether we want to go down the provisioning path for Cisco ACI or not. There are some questions about that. Internally, we're discussing, and I encourage you to reach out to your local contact at Tufin and to tell us exactly what you're looking for. We'll be happy to include you in the discussion. Let's see. Potential roadmap and convergence of Kubernetes and SD-WAN and Tufin platform support. SD-WAN is also something that we are actively looking at. Convergence with Kubernetes, I'm not quite sure what the touch point is, but again, I'd be happy to know directly. So if you want to reach out to me or anyone else on the Tufin team and explain where you see the convergence between SD-WAN and Kubernetes, I'm happy to do that. Perhaps you're talking about edge compute, but I'm not sure. Ofer, I'm going to ignore your question. For IAM, which technology do you support? Okay. We support IAM on AWS, and we support the equivalent technology on Azure, which I think is called RBAC. And so, for instance, when you're applying an RBAC policy to storage in Azure or in AWS, you can manage that in Secure Cloud. No security without control. How do you plan to facilitate audit reports? I agree with the point. There is no security without control. Audit reports it's a little bit too wide, so I'm not sure what it's referring to. So please feel free to ping me online later on. How does zero trust affect the future of firewalls and segmentation? Okay, that's a long question. But a zero trust architecture is definitely a major trend. It applies to machines and people alike. We see that ZTA, zero trust architecture, is talking a lot about enforcement and architectures, but it's not talking enough about policies. If you think about all the problems that I mentioned about security policy, they apply to zero trust alike, just the same. So regardless of if you're doing standard traditional firewalling policies or ZTA, you need to manage the policy lifecycle in a very similar way. So in general, the same concept that apply to security policy management will apply to ZTA as well. Without going into too much detail, that's a high-level answer. One more question. No, scroll up a little bit. The other way around. Okay. Insight about how Tufin can be integrated with our hybrid cloud strategy. Okay, so hybrid cloud, private and public. As of today, TOS, Tufin Orchestration Suite, has support for private cloud. As you probably know, vSphere and NSX and ACI and these kinds of things are supported by TOS, as Secure Cloud itself is in charge of the public cloud part of the stuff. Moving forwards, Secure Cloud and TOS are going to be integrated and consolidated. Reuven mentioned that as well, and we are actively working on that. So eventually you will have that unified policy management across the hybrid cloud. But we'll see how that works out, probably sometime next year. Okay, I gotta finish now. So thanks again for joining us. I hope you have a great, interesting, and entertaining event.